the coordinate is going to be 3, 2. Okay? Yes?
What about dx squared minus 2x minus 1?
Well, if we try it in that equation, we should get the same answer. Okay, let's just take a look with x equals 0, no? Which is the easiest. If we put 0 in here, this term will disappear, this one will disappear also, and we will be left with -1. So we got the same as here. Okay? The same thing will happen if you try it with x equals 3. In the first equation, you should also get 2 as an answer, as y. Okay? Now let's look at them. Would someone like to come and punch them in the program?
Me.
Okay, Vanessa. And I will tell you how to get rid of those in just a moment. I was going to erase like this, but that was not going to happen. Vanessa making her way to the computer. Okay, thank you very much. So if you click on, for example, the point, and then press delete, suprimir. Okay, you make them disappear. And also the lines, please. Okay, so I'm going to tell you what the equations are. First one, and you're going to write it exactly like it's there. In this program, it's important variables go in lowercase, okay, minúsculas. So it's going to be y equals, now x squared. The square is down here in this little box. And then what? Minus 2x minus 1? Okay, minus 2x minus 1. And then you press enter. Here we can see the... Okay, there's a problem. It disappeared suddenly. Well, it's up there, no? There's the equation. Y equals x squared minus 2x minus 1. Okay, so there's a parabola. Now, what we have to see is a straight line that is going to go through those 2 points. Okay? So, the line is y equals x minus 1. Oh, isn't math beautiful? Okay, so this point, the coordinates are 0, -1. This point, the coordinates are 3, 2. Okay, nice, no? Yes?
And how do we get the vertex?
How do you get the vertex of the parabola?
With completing the square.
Yeah, you would. Well, there's 2 ways. Now, it's a good question because you reminded me of something that I was about to forget to tell you. When we have one equation by itself, let's suppose that we have this one, and we find the solutions to this equation. What we would find is the intersection points with the x-axis. Okay, if we solve this by itself, so we would do equal this equation to 0, right? And then by either factoring, which in this case we can't, or using the general formula, or completing the square, we would find the intersection points. In this case, it does have intersection points, but those intersection points are not in a nice whole number. Okay? So, well, we would have to do that. If we solve this equation by itself, by doing x minus 1 equals 0, what we're going to get is the intersection point of that line with the x-axis. This is a lot faster to do. X equals 1. That's where the line intersects the x-axis at x equals 1. Okay? Now, when we make both equal, what we're going to find is not the intersection with the x-axis, but the intersection between the 2 functions, in this case a line and a parabola. Okay? But the process that we're following here, once we make them equal, the process that we're following is the same as if the equation had been this. So it's kind of strange, no? But since this second degree equation, let's say, was born from making a parabola and a line equal to each other. So this quadratic is not going to give us intersections with the x-axis, but intersections between this parabola and this line. Okay, so that's the point that I wanted to make and which you reminded me about. Okay. Now the other thing would be, if we want to find the vertex, the process would be completing the square with this one, and then we could find the vertex. The other way, but in this example it would be kind of difficult, would be to find, we would have to find both roots, and the value of the vertex is going to be halfway of the distance between the two intersections with the x-axis. Okay? So you could find that, and in this case, well, with the graphing program it's very easy, no? Because we can see it's at 1. And then substitute 1 in the original quadratic equation to find this y. And it would be 1 comma negative 2. Okay? So, well, this is the example that I wanted to see. Now I'm going to hand out some exercises so you can do and practice this. Now what we can do is, if you finish the problem and you have 1 or 2 solutions or no solution, and if you want to go ahead and confirm it in the computer, and we can all look at it. But right now I would like to work in pairs. Okay, so I'm going to hand out some exercises. Thank you, Vanessa. And then you will work on these. Let's try to do them all. There are 8, 9 exercises. Okay, so if you can hand them out, please. And 1 for every 2 persons. Okay? And we'll continue with that. And that will be the continuation of the class.